This is 2.4. And we're going to talk a little bit more about linear equations. So last time we talked about slope-intercept form, and again, a better name for that would be not slope-intercept form, but slope what? Slope y-intercept, because that is the y-intercept. You have two different intercepts on a graph. Okay? And we described the slope as a fraction. It's always a fraction that represents what? Okay, how steep the line is, and what else? Okay, and the direction it slants. So the number represents the steepness, and the sign tells us which direction it slants. So on this problem right here, it says name the slope, the y-intercept, and then graph this. Okay, take a good look at this right here. What is the slope on this one? Okay, it's negative 1/4. If there's no number in front of the x, we assume it's a 1. There's clearly a negative there, so it's negative 1/4. And then the y-intercept, the y-intercept is 1. Okay, just a quick reminder, this will come up again. If I write negative 1/4, if I write a negative fraction, there are actually three ways to write a negative fraction. I can write the negative out front, or excuse me, on the top. I can write it out front, or I can write it on the bottom. All of those are negative 1/4. So out front, on the top, or on the bottom. Any one of those three. What I can't do is I can't do this. You wouldn't write the negative on the top and the bottom, because what would it be then? Then it would be positive. Okay, so just keep that in mind. All right, so if we were going to graph this, it crosses at 1. The slope is negative 1/4. Rise is negative 1, down 1, run 4. So it looks like that. If we go 1 point on either side, that kind of makes us feel good. So I'm going to rise 1, not rise negative 1, but rise 1, and then I'm going to go back 4, and this is what the line looks like. Kind of looks like a line at least. Extended forever in both directions. Put arrows on the ends. Okay? So on this one, if we have y equals, this was negative x over 4 plus 1, we can look at it and we can see, well, okay, it crosses the y-axis at this particular point, and then the slope is negative 1/4. Well, let's look at this one right here. What's different about that?
Doesn't have slope.
Okay. Zach says it doesn't have a slope. It doesn't have an x term, that's for sure. So if I had to write it with an x term, since there's not an x period, what would I write? 0x plus 3. Okay. Now let's rephrase this. I'm going to let Zach answer this. What is the slope on this one?
0.
The slope is 0. Okay. And what's the y-intercept? Oops, keep writing that. Slope is, or the y-intercept is 3. So that means it crosses at 3 on the y-axis, and the slope is 0. That means it's perfectly flat. Okay, remember, there'd be something for us to land on if we were dropped on this slope right here. So the slope on that one is 0. So if you have a slope that's 0, then we have what we call a horizontal line. Okay, so this is a horizontal, and that's a TAL at the end, not a TLE. Okay, a horizontal line. So the way I like to think of this is if you have y equals 3, everybody listening please, because this has implications down the road, especially if you take trig and stuff like that. This tells us what the y-coordinate has to be. The y-coordinate has to be 3. It doesn't say anything about what the x-coordinate can be. So as long as you're at 3, you can go as far to the right or as far to the left as you want, and it still makes the equation true. So if we have something like this, if we have x equals 3, then that's telling us something different. On that one, it's saying that the x-coordinate has to be 3, and we can let y be anything. So as long as I go over to 3 on the x-axis, I can go as far up as I want and as far down as I want, and it makes the equation true. So this is the line x equals 3. This isn't a horizontal line, this is a vertical line. Okay? Now, these are two lines that people forget a lot, and they get them confused. So please make sure you get this figured out and get this memorized. If you see y equals a number, that's what that pound sign means. If you see y equals a number, then it is a, which type of line? Horizontal. If you see x equals a number, it is a vertical line. Okay? So make sure you keep those straight. Don't get them confused. Every year when I teach trig, when I teach calculus, people will look at an equation, they'll go, okay, now which one is it for that one? I'm not quite sure. They have to think about it for a while, okay? Now, the way to think about it is, x equals a number tells you what the x coordinate has to be. Y can be anything you want, so you can go up and down. It's vertical. Okay? If it's y equals a number, it tells you what the y coordinate is, how high above or below the x-axis you are, and then you can go as far to the right or the left as you want. So that's horizontal. So if you have to think your way through it, that's fine, but eventually get to the point where you just look at it and you know for a fact, hey, here's what it is. So, quick examples here. If I say x equals 2, that's vertical. Sorry, x equals negative 2. Go to negative 2, go as far up or down as you want, so that's x equals negative 2. If I have y equals negative 1, the y coordinate has to be negative 1. Looks like this. Y equals negative 1. Y equals 1.5. Go to 1.5. Horizontal line there. Oops, we run into the same issue there. I think so. 1.5. Okay, that would be y equals 1.5. Okay. If I had to graph 7/4, I could do it. X equals 7/4 would be 3 1/4, so it would be about right here. Okay, and then the last two are kind of interesting. Where is y equals 0?
Y-axis.
Careful. Okay, y equals 0 is right here. Y equals 0 is an equation for the x-axis. X equals 0 is an equation for the y-axis. Okay? Seems a little counterintuitive. Wait, you're telling me what the y's are and that's an equation for the x-axis? Yeah, because remember, you didn't go up or down. You can go as far to the left or to the right as you want. That describes what the x-axis is. Okay? And then knowing about the x and the y-axis, we can actually use another method for graphing linear equations, and that's to do it by intercepts. And these are really important. We're going to find lots of intercepts in this class. You're going to find a ton of them in every other math class that you take pretty much. So the x-intercept is the point where the graph crosses the x-axis, and the y-intercept is where it crosses the y-axis. So what we're going to point out here, and this is important, if you don't have this memorized, make sure you get this straight because I'm going to ask you a question in just a second and then you're going to hear it over and over and over again. So we ought to notice something about the coordinates of every x-intercept. So if I have a point right here, a point right here, a point right here, a point right here, what do you know about every single one of those? Okay, they're on the x-axis. What about the coordinates for every one of them? The y is 0. So for every one of these, the y coordinate is 0. Every single one of them. So this one right here would be at negative 4, 0. This one would be at 1, 0. All of those have a y coordinate of 0. And if I were looking at any point on the y-axis, every single one of those has an x coordinate of what? 0, because you didn't go right or left. You stayed on the y-axis. Okay? So here's what I want you to notice. Okay? Here's the question. How do you find intercepts? How do you find intercepts? When somebody says, how do you find intercepts, this is what I want you to think. You make a little xy table, you put in a 0 for x, find the y that goes along with it, and you put in a 0 for y. Okay? So we're going to come back to that. I'm going to say that again. You're going to hear that in this class. If I do happen to teach 1050, you're going to hear that from me in that class. So how do we find intercepts? We make a little xy table, plug in a 0 for x, find the y, then plug in a 0 for y, and find the x. Okay? Now, here's a couple questions for you. Just think about these. Could a function have more than one y-intercept? Could a function have more than one y-intercept? Could it cross the y-axis more than once? So, could it do this? Cross here, and then cross there, and cross there. Nope, because the y-axis is a vertical line. We know it has to pass the vertical line test. So the answer is no there. Could it have more than one x-intercept? You bet. We could have a graph going up and down all day long, okay? It can cross a horizontal line as many times as it wants. So the answer there is yes. Okay, so next problem, this is example number 5. We want to graph that linear equation and we want to do it using intercepts. So a little hint here, how are we going to find the intercepts? What have I done here for you? Made a little XY table. What's this? A 0 for X, and what's this? A 0 for Y. So let's go ahead and plug those in. So that's going to be 3 times 0 plus 4 times Y equals 12. So that's going to be 4Y equals 12. That's going to be Y equals 3. Okay? When you plug in a 0 for X, you're finding the Y-intercept. You're finding the number that represents the Y-intercept. Okay, let's do the other one. I'm going to plug in a 0 for Y, so this is going to be 3x plus 4 times 0 equals 12. 3x equals 12, so x equals 4. Again, when I plug in the 0 for Y, that allows me to find the x-intercept. So this crosses the y-axis at, and don't mess these up, make sure you keep the order right. 0, don't go right or left, go up 3. 1, 2, 3, so we're right here. 4, so we're going to go to the right 4, 1, 2, 3, 4, and then we're not going to go up or down. Those 2 points are the line. Now you'll notice that we didn't have to put this in slope-intercept form or anything like that. We didn't even have to know what the slope was or what the y-intercept was, and we got the graph right. Now, you don't have to write this down, I want you to just watch. If this is the correct graph, we should find out that the y-intercept is 3, which we should be able to confirm that here, and the slope is down 3, run 4, so it should be which, positive or negative? Negative 3/4. So I'm going to take this, that's going to be 4y. If I move that to the other side by subtracting, that's negative 3x plus 12, and then I'm going to divide by 4. So this is y equals negative 3/4 x plus 3. Y-intercept is 3, slope is negative 3/4. Confirms it that way. Okay, are there any questions? Sure? Okay, all right. Let's take a look at the end of this. We're going to deal with linear equations a lot, so it's really important that we know how they work. Linear equations can come in lots of different forms. They can look kind of funny sometimes, but the basic thing is this. If we're talking about a linear equation, that's the most basic type of equation that we're going to deal with, okay? It's going to have a plain old x, a plain old y, or both, okay? So a plain old x, a plain old y, or both. Now, when we say a plain old x or a plain old y, what we mean is no squares, no exponents on those, okay? Especially negative exponents, we don't want to see those, okay? No square roots, no logarithms, no trig functions, nothing weird like that. No rational expressions or anything. So, plain old x, plain old y, or both. They can have numbers in front of them, not a big deal, okay? They just can't have exponents, roots, all that sort of stuff. So if we look at this one right here, plain old x, nothing weird going on there. Plain old y, nothing weird going on there. Is that a linear equation? Yes. It is. So we'd say linear. Let's take a look at the next one. Is that a plain old x? No. Nope, it's an x squared. Okay? So we would say that is non-linear. Linear or non? This one's non-linear. Take a good look at this. Linear or non-linear? Linear. Is there a y?
No. Yes.
There's not a y written, but remember y is the exact same as f of x, or f of x is the same as y. So the answer here is linear. Plain old y? Is that a plain old x? Is there something different about this x as opposed to that x right here?
That x can't be 0.
This x can't be 0. You're right about that because we can't divide by x. Okay, if we think of this in terms of, and hopefully you've seen these before, if not, we'll review them in this class. You can actually write this as x to the negative 1. There's an exponent there, and it's not 1. It's a negative exponent. Are negative exponents allowed in linear equations? Nope. So this is non-linear.
Linear.
Very good. This is linear. My question for you is, even though it's linear, is it a function? It's not, because it's a vertical line at x equals 4. So it's not a function, but it is linear. Okay? So it is linear. How about this one right here? This one is nonlinear, and here's the problem. 4x isn't the problem. The problem comes right here. This is 4xy. That's not a plain old x or a plain old y. So this is non-linear. And the last one? Linear. Okay? All right. Any questions? Okay. Now, this is, okay, everybody listen please. Say this one more time. It is not going to be this easy all the way along. Okay? Nearly every day so far, so this is the 5th day of school. You've had some time in class to work, haven't you? Okay? Almost every day but the first one. Okay? So please use that to your advantage. Again, part of what we want to do here is build good habits and good skills. One thing that students struggle with when they go away to college is they don't get used to using their time wisely. They get out of class early, or they have a 2-hour break in between classes. They just mess around and don't get anything done. Okay? So if you've got 25 minutes right now, hop on the computers, get your assignment done, walk out of here all set to go. I could check grades in an hour, and everybody's got 100 on them. Okay? All right. Go ahead and get busy. Thank you very much.